So now that we understand the idea of the null and alternative hypothesis, we want to talk about how we're actually going to go through and formally test our hypotheses. So as you will see as we go out throughout the semester, we're going to be doing multiple hypothesis tests. And all of them are going to have the same format of these 5 steps. Inside each note packet, they're going to look a little bit different, but it's going to follow the same process. So let's talk through what these 5 steps are. So our first step is just always going to be to label our hypothesis. So basically tell me what your null hypothesis is, tell me what your alternative hypothesis is. So we're going to start by just writing those out. Our second step is what we call our decision rule. Now what we have learned in previous videos and notes is that the smaller the probability, the more likely I am going to be to question the claim. So what I'm going to write as my decision rule is then I'm going to reject that null hypothesis or no longer believe that claim is true and instead believe my alternative hypothesis if our p-value, and if you remember from last time, our p-value is just a probability that we calculate here. Right, so it's just going to be another name for a probability. So if our p-value or probability is less than whatever our alpha is, and alpha was this significance level that we talked about right here. So if we don't know anything else, we assume it's the 0.05 number for that. So this is sort of our new symbol that we have. And that step 2 is always going to look like that. This is always going to be a less than sign there. So keep that in mind as we continue as well. Step 3 will be checking our conditions and calculating our test statistic. Now conditions will be on your formula sheet. The test statistic formula will also be on there. So basically step 3 will be on the formula sheet for us. Step 4 will be to calculate our p-value or calculate that probability and then make our decision. So in order to calculate this p-value, I need 2 different things. So I'm going to need my test statistic and my alternative hypothesis. So I need to know if it's like a one-tailed versus a two-tailed test. So that's going to help drive what my picture looks like. It's going to drive my probability. Once I have that p-value, I can go back up to my step 2 and make my decision if I'm going to reject or not. Step 5 is going to be our interpretations. And we've seen the idea of this interpretation before. It's what we did in our one categorical variable part 1 notes. Then we're also going to talk about how to write a conclusion. And these formats are going to look very similar regardless of which set of notes that we are in. And they make a little bit more sense as we do our first example. So again, these are the 5 steps that we're going to go through for any hypothesis test. Now in this set of notes, let's look at what those 5 steps look like. So our null hypothesis is going to be that p equals p0. This p0, when you're actually doing a hypothesis test, will be a number. For the alternative hypothesis, we're only going to choose one of these 3 things. I have to decide if I want that not equal to, the less than, or the greater than. And here I'm going to choose based upon our goal. Do I want to see if this value is less than this value? Do I want to see if it has gone up? Or do I want to see if it has changed? I'm going to have to read the problem to make that decision. That decision rule is going to be the same as it was on our previous page. And since it never changes, it's good to practice writing it out. So we're going to reject our null hypothesis and instead believe the alternative hypothesis if that p-value or our probability that we calculate is small enough, smaller than whatever that alpha level is. Now for our step 3, these conditions should look quite similar to what we've seen before. The main difference is that instead of having P, this little 0 is on the P instead. And the main reason for that is to know where that number comes from. So this number down here is the same as this one up here. So whatever numbers in the null hypothesis will get carried down to those conditions. Now our test statistic is going to look a lot like what we've seen before. In fact, I'm going to write it out from what we had already seen. So in our one categorical variable, part 1 notes, this is what my z looked like. There's just going to be one tiny difference, is that these p's have that little sub-0 on them to again say that this number is whatever number shows up here. At that point then we can calculate our p-value. So I'm going to need, again, my alternative hypothesis and then my z, make our decision, and interpret it. Now it's really hard for many students to understand this until we go through and do a real example, so that's what we're going to do with our Oreo data. Now, when I had both classes of data, I'm going to show you what we got. So in my 11 a.m. class, we had 25 students get the Oreo guessed correctly, and we had 9 students guess it incorrectly. In my 1 p.m. class, we had 16 students guess the Oreo correctly and 14 get it incorrect. So I'm just going to total those up across here. So we had a total of 41 students get the Oreo identified correctly and 23 students that got it incorrect. So then my total sample size, I'm going to add those two numbers together to get our 64, so a total of 64 students. And our proportion that got it correct will be 41 out of 64, which is 0.6406. Now we did discuss in class already what our hypotheses should look like, but let's go through that again. So our first step is to go through and identify the null and alternative hypothesis. So our null hypothesis, what we assumed to be true until we knew otherwise, was that p equaled 0.5. What that really meant for us is that you all can't tell the difference. So I gave you 2 cookies and asked you to tell me which one was the Oreo. If you had no clue, you would guess it correctly half of the time. Now, as we discussed, the alternative was going to be the greater than 0.5, because then you're doing better than guessing, so that means we really can tell the difference. Okay. All right, our step 2 here is that decision rule. So we are going to reject the null hypothesis and instead believe the alternative hypothesis if our p-value is less than our alpha. I didn't give us an alpha in the problem, so we're going to use the standard one of that 0.05 that we saw here when we talked about the significance level. Now our next step is to do our conditions and our test statistic. So first let's go through and do the conditions. So let's first talk about how we did our sample. And we spent quite a bit of time in class just discussing how we were actually going to go through and design this. So assuming that no one went against what we decided, like you closed your eyes, right? We randomized which cookie you ate first. We tried to control all that bias that we possibly could. So that part should feel alright. Now my n times my p0. So our n was our total number of students up here, which was 64. Our P0 is just this number that shows up in our null hypothesis, or that 50%. So we get 32, which is at least 10, and the n times 1 minus P0 is also going to give us 32, which is at least 10. Now those two numbers should sort of make sense. So if people cannot tell the difference between the Oreo and the Kroger brand cookie, half of them would get the cookie identified correctly, and the other half would get it identified incorrectly because they were just guessing. So that's what that number is doing. Next, we're going to do that test statistic calculation. So if I go back and look at the formula, we already have our p-hat labeled at the beginning of our 0.6406. I know my p0 is going to be the 0.5, and I know my n is going to be the 64. So we know all of our numbers. So our z is going to be our p-hat, our 0.6406 that we have up here, minus our p0, so that number in the null hypothesis, over the square root of p0 times 1 minus p0 over our n of 64. Now up until this point, we've usually already done this square root calculation, so it's probably good for many students to sort of break this up. So I'm just going to do the numerator first and do my little subtraction. And then on the bottom, just do that square root calculation to kind of break it up a little bit better here for me before I actually do the division. But no matter how you do it, you should get a z of 2.25. All right, next we're going to calculate our probability. So I'm going to start by drawing our picture. And I'm going to draw the picture in two different ways. I'm going to draw it first like we would have in the previous set of notes. All right, so I'd have my picture here. It'd be centered at my P, which I'm assuming is 0.5. Go out in my increments of my standard deviation, which is at 0.0625 here. So first I'm going to go to the left. So I'm going to subtract off that number. So I would get 0.4375. 0.375 and 0.3125. Next, we're going to then add it to the right. So I would get 0.5625, 0.625, and 0.6875. And then I would have taken my value of p hat, put that on my picture here, which is roughly here. And then have to figure out which way to shade. Because of this greater than sign in my alternative hypothesis, it's going to tell me then to shade the greater than, which would be to the right. So keep in mind all the things that we talked about before. So I would have talked about, well, I can tell my z is going to be between 2 and 3. Notice it is. I know that I'm going to have to use the 1 minus rule since we're shaded right. And I can tell my answer is going to be less than 50%. So all those same things that we talked about are true. Now I'm going to take this exact same picture and draw it in a slightly different way. And these two pictures are going to be equivalent to each other. So the picture I drew over here in this pink color is based upon p hat. Now I'm just going to draw it based upon z. So z is always centered at 0. Because right, if my value was exactly 0.5, I would be 0 standard deviations from the mean, so that equates to a 0. This 0.5625 would be a 1 standard deviation away. The 0.625 would be 2 standard deviations above. And the 0.6875 would be 3 standard deviations above. And then doing the same thing in the opposite direction, but they'd be negative since we're below the mean. So 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. So hopefully you can see how that picture is really doing the same thing. Now I've already done my z calculation. It was 2.25, which falls roughly here. And again, since my alternative hypothesis is a greater than, I would shade to the right. Okay. So those pictures are really exactly the same. I'm going to get away from drawing this one, because this one's a lot easier to draw. These numbers are always going to be the same along the bottom, because that middle number is always 0 standard deviations away. This one's always 1 above. This one's always 2 above. So this picture is nice and easy and consistent every time I do it. So then when I actually go to my table here and do my p-value calculation, which again is just now a new fancy word for probability, I know I'm going to have to use the 1 minus rule, just because of the fact that I'm shaded to the right. I look up that 2.25 in the table and find 0.9878. So then if I do that math, we're going to get 0.0122. And so again, all the math is the same as what we were doing before. Now here's a little part that's different. I have this p-value. I'm going to go back up here to step 2. I'm going to check, is my p-value, 0.0122, less than 0.05? Well, that is actually true here. So since it is true, we will reject the null hypothesis and believe instead the alternative hypothesis. So now hopefully you can see why the interpretation, that last part, is going to be important for us. So we're going to be doing 2 interpretations. So this is our step 5. So I'm going to do the first interpretation like we've done before. So assuming people can't tell the difference, between the 2 cookies, and so what I'm really saying there is that our p is 0.5, right? They can't tell the difference. The probability that. Now before I interpreted this picture, I'm getting away from this picture, so I'm going to interpret this one. So the probability that our data was, we're shaded right, so I'm going to say at least our z was 2.25. Their units are standard deviations. Above that, because it was positive, is our 0.0122, or 1.22% chance. So basically, if you all couldn't really tell the difference between the 2 cookies, there would be a little bit more than a 1% chance of observing our data. So it should rarely happen. If you can't tell the difference, that makes us believe that you can tell the difference. So that's what's going to go on with our second interpretation, which is our new one. So going back here, it's going to be following this format. So we're going to start with our alpha level. So our alpha is 0.05. The next part is either to say there is or is not statistically significant evidence. Now for that, when we said statistically significant, it means we rejected the null hypothesis. So did we reject the null hypothesis in our example? We did, so we're going to say it is. So whenever you see this is, it means that you rejected the null hypothesis. The is not is when we did not reject the null. So that's how we choose that wording. So we're going to say at our 0.05 level, there is statistically significant evidence. To support and then our last thing is the alternative hypothesis, but in words, not symbols. So there is evidence to support that you can tell the difference between Oreo and Kroger brand cookies. All right, so that's our first hypothesis together. We will be going through and doing a couple more together in class.